Now let us clarify the concept, the model of overbooking through an example. Let us assume that V is equal to R is equal to $10 per unit of inventory. Now suppose that the show up rate is distributed uniformly. So it follows a uniform distribution over the interval with a value of 0.8 to 1. So the minimum is actually 0.8 and the maximum is 1, and there are equal chances of getting anything in between 0.8 to 1. That is the uniform distribution. And that the PDF for capacity, actually I will not talk about that how does actually the show up rate is uniformly distributed. It could be exponentially distributed as well. It could be normally distributed as well. It depends upon the history. So history of the organizations are actually, the distribution is actually fit on that show up rates, and whichever is the best fit, the airline industry would follow it. So the best fit, किसी industry के लिए best fit is the uniform distribution जो show up rate के लिए हो रहा है. The best fit distribution would be used with its parameters. And the PTF for the capacity, that is PC is equal to small c, is given as below. So the value, we have the probability for capacities. The probability of 100 is 2 by 5. The probability of having the value of 110 is 2 by 5. And the probability of 120 is 1 by 5. The probabilities are taken in fractions. You can take it in decimal points as well. So our FB based on the show up rate is 5. And 0.8 is the lower limit of P and 1 is the highest limit. And mu B is 0.9. This is the mean value of the uniform distribution given. So from the example, we can actually compute from the solution which we actually got from the overbooking model. The last solution would look like this expression, that is 2 by 5, 0.8 to 100 over L, 5 BDB plus 2 by 5, 0.8 100 over L, 5 BDB plus the last one would be 1 over 5, 0.8 to 120 over L. So the values are actually C's, 5 BDB, and it should be equal to the expression that was V into mu B divided by V plus R. So it actually leads to the value of 2.05. So the overall expression after integration would be 29,300 divided by L square is equal to 2.05. And thus we can actually calculate L. L would be 119.55. The evaluation of expected total cost at L is equal to 119 and L is equal to 120 by using the previous expressions which we have actually gives the value of 83.29 or between 83.29 to 83.33. If you do not want to do that interpolation, any one value would be fine as well. And the optimal value for L will be 119. I would say even 119.55 is fine. You do not need to interpolate the expected total cost for L is equal to 119 and 120. So either 119 or 120 would be fine as well. So any value of L here would suffice. So interpolation might, if you do not want to do it, you might not do it. You can actually leave the last step. So expected total cost at two different values of L is not required. So students, now you know that how would the overbooking model actually works. So here in this example, we have L equal to 119 or 120. So overbooking level means this much should be overbooked. So either 119 or 120, it doesn't matter. You are not required, or you are not required to actually interpolate between these two values, that which one is the better one. Even it would be good enough if you take the overbooking level as 119. It would be fine if you take it as 120. Thank you.